Okay, in this video we look at how to find the equation line through 2 points. So consider, for example, we want to find the equation line that goes through the points 2, 4 and negative 5, 6. Again, the process we have is that slope-intercept form, which requires us to know the slope and the y-intercept. So in this problem we don't know either one. Neither one of those points is a y-intercept, and really neither one of them is a slope. But what we can do is recall now, since we have 2 points, we can use our slope formula to find the slope, and that's what we do. We take the difference of the y's, 6 minus 4, over the difference of the x's, negative 5 minus 2. Remember, when using the slope formula, the most important thing is to keep the same order in the top and bottom, and then just be careful with your arithmetic. 6 minus 4 will be 2. Negative 5 minus 2 is not negative 3, it is negative 7. So we'd have 2 over negative 7, which we could rewrite as negative 2 sevenths. Okay, once we know the slope, we can go ahead and write that down. Now, in problems that we've looked at before this, we had a single point, and we plugged that in now to find our y-intercept. Well, if you think back to that visual picture. In fact, let me give you a hand with that. Right, we were saying, given a point, we can backtrack along with the slope towards that. Well, if you're given some other point on the line, you can also backtrack from that point to the slope. So what we're saying here is that it doesn't matter which of the 2 points that you use. You can always backtrack to the slope. So I can pick either one of those points, 2, 4 or negative 5, 6, and it'll work out. So I say let's use 2, 4, since they don't have any negative signs. Plug that in. I get 4 equals a negative 2 sevenths times 2 plus b. Simplifying each side, I get 4 equals negative 4 sevenths plus b. So to solve for b, I need to add 4 sevenths to both sides. And that would give me 4 plus 4 sevenths, which is better known as 4 and 4 sevenths. But then 4 and 4 sevenths could be rewritten, if you want it, as a mixed number, 32 sevenths. Either one of those values would be fine. 4 and 4 sevenths, if you want to write that y-intercept as a mixed number, you can. Or as the improper fraction form, 32 sevenths. Typically myself, I'd prefer the 32 sevenths. And then we can write our equation, y equals negative 2 sevenths x plus 32 sevenths. And that would be our answer in slope-intercept form. Okay, let's consider a second example now. Let's say that our line goes through the points 3, negative 1 and 7, 5. Maybe you might want to pause the video and start trying to work this problem out on your own. Okay, so hopefully, if you've taken time to do this yourself, you've now found that the slope, we would do the difference of the y's over the difference of the x's, so 5 minus a negative 1 over 7 minus 3. Alright, get a slope of 6/4, which would simplify to be 3 over 2. Okay, once we know our slope, we can plug that into our formula. And then, as we discussed before, pick either one of the 2 points, either 3, negative 1 or 7, 5, to plug in for x and y. In this problem, I picked the 3 and the negative 1. So negative 1 goes in for y, because it's the y value. 3 goes in for x. We have negative 1 equals 3 halves times 3 plus b. We can simplify. 3 halves times 3 would be 9 halves. So negative 1 equals 9 halves plus b. And then at this point we want to solve for b, so we subtract 9 halves from both sides. And when we do that, we have negative 1 minus 9 halves. So to simplify that, we'd have to get a common denominator. And so that would be negative 1 become negative 2 over 2. 9 halves, we already had it, so negative 2 minus 9 halves Be negative 2 minus 9 would be negative 11 over the common denominator of 2. So our b value, our y-intercept here, is negative 11 halves. And so we can write our equation down. 3 equals, or y equals 3 halves x minus 11 halves. Now sometimes, instead of having your equation in slope-intercept form, as we've written both of these here, you may be asked to take that equation and put it in general form. If you go back a video, general form was discussed and how to do that, but we'll review it here as well. Remember to put an equation in general form. We want the x's and y's on the same side and no fractions. So we take our equation here, multiply by 2. And when we do that, we'd get 2y equals 3x minus 11. And then finally we say we need x on the same side as y. So we can subtract off the 3x from both sides. We get negative 3x plus 2y equals negative 11. And then finally, we want the x term to be positive, so we multiply both sides by a negative 1, and we get our answer 3x minus 2y is equal to 11. So now our equation is in general form. Okay, in the next video we'll look at finding equations of lines that are either parallel or perpendicular to a given line.